Hi, everybody. My name is Thanet Knack Praneenararat. I'm working as developer programs engineer based in Tokyo. And today I'm very happy to have an opportunity to give you a talk about the best practices of the Google Ads API. And this is the agenda of my talk today. I will start with the value of best practices, and then I will mainly talk about how to efficiently fetch, create, update, and remove your data. And after that, I will cover error handling, which is the concept borrowed from the AdWords API, but still hold true in the Google Ads API. So why are we interested in best practices? The best practices can sometimes be defined as the attempt to achieve the difference between this graph and this graph, provided that the graph represents something that your business cares about, like the time to execute operations. So the lower is the better. So when you can execute your operations per second, like more and more, it means that you can serve more accounts and more customers. And finally, it means that you can provide more business values to your customers. And that's why we are talking about best practices today, because it's good for your business. And when you follow the best practices, it's more likely that you can achieve this difference. So who is interested in best practices? We can divide the API stakeholders into two groups, the developers and the Google's engineers. The developers, or you, actually understand your product very well and also understand how your technology stack operates. And the Google engineers, on the other hand, understand the APIs very well and also understand the interfaces of the infrastructure. Although two groups seem to be quite different, actually they have a common interest, which is the interest in saving time, money, and resources. So what are the benefits of following best practices? So the first and obvious benefit is the performance and scale. You can do more things with less effort and by using the efficient techniques. And you can scale up to demand very easily when following best practices. Secondly, you have shared understanding with us. So with the shared expectations, it means that you will have fewer surprises because you understand how the API works, and in the meantime, we understand how you intend to use it. So over time, we can predict or optimize our software components to better work with your data patterns or query patterns. And finally, the stability. When you use the best practices, you can rest assured that you will have consistent and reliable system to use, because best practices are tried and tested. And every time we add a new thing in the Google Ads API, we ensure that they are validated with the best practices, and so that the best practices still hold true at all times. So let's get started with the first main topic of my session today, which is data fetching. In the Google Ads API, one of the common misconceptions is that Google Ads query language is SQL. Actually, it's not. Although it looks similar to SQL, they're not the same thing. It is built on the top of the system that requires you to explicitly select fields, metrics, and segments, so that it can translate your query into a request in the backend correctly. And that's why we like to encourage selecting only what you need in order to reduce the size of the responses, as well as unnecessary fetching of the resources. And this will ultimately help our Google engineers to optimize for the data paths that you actually need. So in short, have a look at the top query of this slide. We would like to encourage you to do something like that. Select only what you need. In this case, we select only add group criterion.criterion ID and the metrics.impressions, which is pretty concise. On the other hand, in the below query, as you can see, we select so many things in this example, and it's not quite effective. So think carefully about which attributes, metrics, and also segment fields you would like to request. Requesting unnecessary fields can make the query more expensive because additional resources are required behind the scenes in order to generate your results. So more efficient queries mean more queries processed per second. We have done an empirical test on selecting some keyword metrics. So in this graph, as you can see, the left-hand side is the case when we selected all the metrics of the keyword view, and the right-hand side is when we selected only one required metric. And this graph represents the time to download keyword metrics per account. So the lower is the better. So based on our test, we have found that when selecting only one required metric, it could save up to 50% of the time when compared to when we selected all the metrics. So a better understanding of the Google Ads API infrastructure and mechanism like this can make you be more effective. Let's have a look at another example. This is simplified Google Ads API architecture. And we have 3 layers here: Google Ads API, the caching layer, and finally, the backend databases. So when you send a request, like search request, to the Google Ads API layer, it will translate your query into the request to the backend databases. And after that, when it can figure out what the results to be returned to you, it will be returned via the cache layer. So the result will be returned via the cache layer and saved there before returning back to you via the Google Ads API layer. So in case you use paging request, which also available in the AdWords API as well, and request for a next page, what happens here is instead of going deep down into the databases like the first page, it will be passed to the cache layer instead, and your result will be returned almost immediately from the cache layer back to you as a response. And that's exactly the benefit of using paging request. So to use the paging request, what you need to do is to pass a page size parameter to the search method, like shown in this slide. Apart from passing the customer ID and also the query string, you can pass an array of the page size like that. The Google Ads API will internally catches the following pages so that the subsequent requests are faster than the first one. And as you can see in this slide, we use the PHP library, meaning that all the client libraries actually support handling the pages for free. We have done another test for this particular feature. And by using the sample query like shown in this slide, we set the page size equal to 1,000, and it resulted in 360 separate requests. The size of the response is almost the same for each page because we send the same amount of the requests and also get back the same amount, almost the same amount of the response size. So for the first page, it spent around 16 seconds. Whereas for the subsequent pages, it took only around 1 second. This is because internally, your subsequent pages results are already cached. And in this case, the more important thing to mention here is to tweak the page size appropriately to reach the sweet spot between the number of the results in a page and the number of queries to be sent. Actually, this depends on your business requirements. So unfortunately, we don't have one-stop solution or a universal number for the page size. You need to find that spot by yourself. But the important thing is that you wouldn't want to use too large page size or too small page size. Apart from that, know that these numbers are extracted by using the REST API. So when you use client libraries or gRPC requests, the number might be a little bit different, but the performance improvement here is still approximately the same. So apart from using the paging request in order to reduce the size of a request you can also use segmentation by date in order to reduce the overall number of the returned responses and also the size of the responses. So to use the segmentation by date, you can do so by using the flag clause like this, specify the filtering condition by using the specific date or a date range. And in this way, you can further reduce the size of the response. Without an individual date or date range, you could be requesting all the data at all time. And imagine that you have a long historical data. This could result in the increase of the time it takes to generate your response. And apart from date segmentation, actually we have another option for you, which is the filtering condition. Like you can use IDs, statuses, and other metrics and attribute fields to filter your response as well. One of the two popular filtering conditions that you can use is first, metrics.impressions greater than 0, which makes sense in many cases because you are probably interested in only the data that perform, like only the ad group ad that perform or the ad group criteria that perform. So whenever the impressions is 0, it means that they're not performing at all. Another one is the status. You can filter like this, ad group criterion.status equal to enabled, meaning that you want to fetch only the ad group criterion that are not yet deleted. The next topic is about creating, updating, and removing the data. So to create multiple objects in Google Ads API, we have a feature called atomically creating objects. And this is actually partially available in the AdWords API as well in the batch job service. In case you use the AdWords API, I think you might be familiar with this concept. So atomicity means that your operations all work or all failed. So you will not end up in a strange situation when you are trying to create a campaign budget in order to be used in the campaign operation creation. But somehow when you're trying to create a campaign operations, somehow the error occurs and then you cannot create any campaigns at all. In that case, you might have already created some campaign budgets, right? And that will put you in a situation in that you have many dangling campaign budgets not in use at all. So to avoid that situation, you can use this atomicity concept in order to create all campaign budgets, all campaigns together, or not creating them at all. So to do so, in the Google Ads API, what you need to do is to send your request to the Google Ads Service.mutate method together with temporary IDs, which is actually the negative value as references. So here, shown in this slide is actually the example of the request, and we have hidden some of the mutate operations and here to show only what is needed, and because of the space limitation as well. As you can see, the campaign budget operation here, you can create the campaign budget by populating many fields here. But what is different here from the normal situation is that you need to put the resource name field here too. Okay, so in other normal situations, you may just populate other fields like the amount of the budget and etc. But in case you want to use atomicity, you need to put the resource name field. And in this case, we use -1. Actually, it can be any negative values, but it's good to start from the -1 so that you can keep track of what numbers you have already used. Okay, so after that, when we are trying to create a campaign here down below, as you can see, when we want to specify the campaign budget, in normal situation, we usually use the real ID, right? Which would be something like a long digit number. But in this case, because we want to create them all together using the atomicity concept, we need to reference the campaign budget here by using the negative values. Okay, so this is exactly the same as this. And note that we also set the resource name for the campaign here too, as -2. So in case you want to create ad groups After this, you can refer to this campaign ID. And the same, when you want to create an ad group ad or ad group criterion, you can set a temporary ID for the ad group. This will result in better consistency and performance overall in your account. The next thing that I would like to share in this session is the updates. So in the Google Ads API, as you have seen a little bit in the previous sessions before, we have made a significant innovation of the Google Ads API for updating objects. It is called field mask. So it requires you to explicitly describe which fields are to be updated. So at first glance, you may think that it's actually more work for you, right? You need to further provide another field when you want to update things, but it actually can resolve ambiguity for you. So in the AdWords API, when you want to update some data and you also store your data in the local databases, you may just fetch your data from the local databases, modify some fields, and then send back to the AdWords API, right? As is. So your object may contain many other fields that you actually have not updated them. But the AdWords API will not know what fields you actually want to update. So the AdWords API will update all the fields present in your request, and it's not quite effective, as you can see. Alternatively, you can create a new object every time you want to update things and populate only what is required. That's probably fine. Actually, it's more effective in the AdWords API server. However, you need to do that by yourself, so it's quite cumbersome. That's why in the Google Ads API, we combine this concept together. You can use whatever fields here as you want. You may just fetch other fields here from your local databases, but at the end of the day, you may want to update only the name. So you can go ahead, update the name, and then in the field mask, just specify that, okay, the name field is the thing that I want to update, not the status, not the other fields. Next, about remove. In the Google Ads API, to use the remove operation is pretty easy. You just specify the resource name here as the remove field for the operation, and that's it. You can remove objects, any objects in the Google Ads API by using this kind of code. However, in the Google Ads, note that I'm using the words Google Ads, not the Google Ads API or the AdWords API, but I mean the Google Ads in overall. Objects are not permanently deleted, and that is because we want to preserve metrics. In case you want to still fetch some reporting about the historical data, you can do so by using Google Ads Service.search and get back your removed objects performance data. However, even though they are not permanently deleted, once they are removed, they cannot be re-enabled. Okay. Another thing I would like to share with you about the remove of objects in the Google Ads API is in the AdWords API, when you use campaign service, ad group service, or any other services to fetch your data, the removed objects will be filtered out automatically. But in the Google Ads API, because we provide you more flexibility, you need to be more explicit. So in most cases, you probably want to put this condition in the web clause, like the campaign.status not equal to removed. If you omit that condition, it will return you all the objects that you have in your account. And most of the time, you may not be interested in fetching the data of the removed objects anymore. So please be aware of that. Finally, I would like to briefly talk about the error handling here. We have 4 types of errors, actually the same as in the AdWords API. And the first one is the retrievable errors, which are the errors that are actually transient. And most of the time, you may just wait for some time and then retry the requests, and it can go through. Okay. So in this case, we are recommending using the exponential backoff policy, because in that way you can ensure that you're not ended up being rate limited because of too aggressive request sending. The second one is the validation error, which happens when your input is not valid or not acceptable, like you're trying to set too large or too small IDs for an object, or you're trying to set an immutable item. The third one is sync related, and it happens when you are storing your data in local databases as well, and you are trying to modify things that are already, for example, removed. That can happen because maybe you are handling the data for your customers, and in that case, your customers have access to their accounts as well, and they may just remove something already, and you are not aware of that. So in this case, we recommend using the change status service to keep track of what has changed since the last time you have synced with the remote databases. Finally, authentication errors, actually one of the popular errors that most beginners will encounter. And it happens mainly because of the misunderstanding about the credentials information concept. And for particularly the Google Ads API case, it can happen when we have started requiring the login customer ID, the new HTTP header that I think we have covered in the keynote session as well. In that case, if you do not provide the login customer ID, you end up with the authentication error as well. In the next slide, I will show you the review of the concepts of the credential information. But for now, I would like to emphasize that the links here are actually very useful. So when you have time, make sure that you go over them. Okay, for the credential information used in the Google Ads API, we have many concepts. A developer token is actually analogous to a driver's license. It means that you are allowed to drive a car, right, when you have the driver's license. But the license will not tell you what car plate numbers that you can drive. Similarly, the developer token in the Google Ads API just allows you to use the Google Ads API itself. It doesn't define what accounts you can access. So that's why we have another concept. It is access token, which is analogous to a key of the car. It allows you to drive a specific car, but for a certain amount of time. So the access token similarly allows you to manage a specific account for a certain amount of time. And after that, it will be expired, and you need to generate a new one. So to generate a new one, we have a refresh token, which serves as a utility for you. In case your access token is already expired, you can generate a new access token by using the refresh token. And in case you use the client libraries and provide developer token and refresh token ready, you can just rest assured that the access token will be generated automatically when needed. And yeah, to summarize, best practices can help you be more efficient and do more with constraints. And also we suggest sending optimized queries by, for example, using a paging request or using filtering conditions and segmentation by date in order to squeeze down the size of the response to help you request the Google Ads API in a much quicker way. Thirdly, understanding the Google Ads API infrastructure, such as the paging request mechanism, can be useful to your business as well. So ensure that you will understand the infrastructure I have shown to you in this session very well. Next, be aware of the methods to efficiently update the data. Now, in the Google Ads API, we have provided you the field mask mechanism, so you don't need to send everything and let the Google Ads API figure by themselves whether or what fields you are trying to update. Or you don't need to create a new object every time you want to update things anymore. And finally, understanding common handling actually is a key for your stability of the application. So ensure that you review all the concepts available in the best practices guide and also in the error guides. This is the resources list. It's pretty the same as in the keynote and also the overview sessions, but I would like to highlight here the best practices guides. We have provided the Google Ads API Best Practices Guide and also the AdWords API Best Practices Guides as well. And that is because the AdWords API Best Practices concepts mostly are still applicable in the Google Ads API. So it's no harm to maybe review some concept in that guide too.